So let me first start by saying hello. My name is Bryan Brown, and I am a professor of science education at Stanford's Graduate School of Education. And so what I want to do is share briefly some big ideas associated with the research that we've conducted over the years on language and science instruction. And so I think the overarching premise, what you're working on today, is this idea that when we're learning science, we are essentially learning two things. We're learning science ideas, but we're also learning new language practices. And so whether those language practices are symbols or those language practices are new words, we have to make sure that we teach them. And so I'll say it differently. Sometimes the same idea will have a new word, but I understand that word in a different context. And so I think of pressure, right? There's a lot of pressure on me to do my homework, to clean my room, but we're talking about pressure in science. We're really specifically talking about a relationship that is indicative of how much space and restricted numbers of matter within that space. And so the challenge is, how do we make sure everybody is learning? And so our research group has done about 10 years of research exploring how do we make sure everybody is learning science. And so here's the easy thing for us all. The first is that what I can assure you is that if we teach the language, students will learn the language. And here's what I mean. If students have lots of opportunities to practice using the science language, they'll learn it. So the question is, what are most of us doing? When I started teaching, I used a lot of prefixes or word walls. I'd love to tell those kids, as a biology teacher, if it ends in ace, it's an enzyme, right? Well, that was a helpful tool for me, but as a teacher, I had to ask, how am I teaching so that they are learning the language of science? And so I want to share some research to you all today. Hopefully, this will help as you move forward. So the first question is, how do we study how complex language would impact students' learning? So here's what our challenge was. We had to first create two conditions, a control condition. Here's a control condition. I assumed every good teacher makes an effort. So a control condition for our case was you're going to use science language and you're going to use everyday language at the same time. So our treatment condition was a little bit different. So in our treatment condition, students were just given the idea in simple language, and then we taught the science language separate. So the idea is, let's just make it as easy as possible. Let's use accessible everyday language first, science language second. So here's a quick example. So in this image, you'll see this was a representation of photosynthesis. So one group got this: oxygen, carbon dioxide, photons, and water. So photosynthesis is a combination of photons and oxygen and water that produces the byproduct of carbon dioxide. So that is our control. The alternative, we just wanted to make sure language is easy. So these students got the same image, but here's what they got: light that comes from the sun, good air that all humans need for breathing, air that humans breathe out, and water. So this is the same kind of equation, is that in order for photosynthesis to happen, the plants use the bad air that humans breathe out, they use the sunlight, and then they give us back good air that humans use. And so same ideas, the words were different. And so the question is, how does that impact learning? So we gave them pre and post tests. And what we found is on all items, these are all statistically significant, that those who are taught with simple language only and then given an opportunity to use the science language, that those students vastly outperform those who got both science ideas and science language at the same time. So we gave them three measures. One group got multiple choice questions that we called overall. So these were both complex science questions and simple language science questions, and we saw a significant difference there. The other group got what we call disaggregate questions. So when the question used very few science terminologies, very simple language, again, those who are taught with the treatment condition vastly outperformed the students. You notice their gain is slightly above 72%, where those who were taught with everyday language, science language rather, were approximately 58%. Now, the closest difference when both were taught with complex science language, so when the questions were assessed by using complex science language, both did worse, but ultimately those who were taught with simple language still did better in learning the science language overall. The biggest differences are found on the right. When we use open-ended items, meaning the students were just given an opportunity to write what they know across all measures, overall meaning every question, disaggregate meaning when the question was written in the simple language, or if the question was written with science language, where the students had to write it to explain it themselves, the students who were taught with simple science language vastly outperformed all students. So we replicated this over the course of several iterations, and it was picked up and replicated by scholars both in the UK, in Switzerland, and at the university level here in California. And across all these iterations, those who are taught with simple language first, then who are given an opportunity to communicate what they learned in science language, vastly outperform those who are taught with simple science language alone. So as a team, this body of research led us to two key ideas and things that I want you to use as tools. The first is when science is taught with simple, everyday language and concepts first, followed by allowing students to practice science language, those students improve their learning and retain that information at higher rates than their counterparts. Secondly, compared to trying to learn both science and language at the same time, when students were taught with the concept first and language second, it increased their retention. So the message is that when we're learning science, it's almost like we're learning both an idea and a language practice together. It always behooves us as educators to support students' learning by making sure every student has an opportunity to practice that language until they become experts. It's almost the way that we did. Once we teach it, you really have to find ways to think about it for clarity, and we ultimately learn how to communicate those ideas in accessible language. Students deserve that same opportunity. Thank you for your time.